Mobile phones are now fast becoming complex miniature computers, which is opening up the opportunity for companies to devise innovative new uses for the technology. Spearheading the work are people like STEM career role model Chris Stiles.
Hi, I'm Chris Stiles. I'm a Senior Applications Engineer here at ARM in Cambridge.
ARM, or ARM, specialises in designing computer chips for mobile phones. The chips are cheap and require very little power, so are ideal for embedding into other technologies. It's Chris's job to come up with additional uses for the chips by inventing completely new devices. He's been working with local schools to develop a unique project for use in teaching electronic engineering by making the technology easily accessible to pupils.
It seems strange sometimes that students stand outside their technology classroom, the bell goes, and they then have to switch off their mobile phones, take out their Bluetooth earpiece, pack away their iPod. They then go into a classroom and shown LEDs and buzzers and switches and told that that's what technology is. There's a discontinuity there somehow.
Chris wants to address this discontinuity by taking mobile phone processors into the classroom and showing the relevance of science, technology, engineering and maths.
I think what excites me about engineering is having the problems to solve and accomplishing an outcome. So you may come up with a really good idea on the back of an envelope and a bit of hard work and engineering and mathematics later, and you've got something in front of you that works. At the moment, I'm working on a project that doesn't really relate to my actual job here. It's a project called Embed. It started 4 years ago because I was doing lots of STEM work, doing visits to schools. I was trying to use what technology we had available, and it always got in the way of our STEM activities. So we went away and did a bit of research and was looking at what the problems that we actually faced in schools. And 4 years later, we've actually got an engineering solution that is commercially attractive. So while it was born from a STEM objective or a STEM requirement, it's a real functioning product now.
And this is what his 4 years of hard work has produced.
So this is the Embed microcontroller. It contains an ARM-based processor, and it allows you to write code to interact with the real world. So if you have sensors or some kind of communication or output device, it allows you to interact with them.
Today, Chris has brought his device to Linton Village College in Cambridge, together with 4 experiments that will allow the pupils to program the chip to do very different things. Controlling a robot, making an ultrasonic rangefinder, an innovative locking system, and capturing the trajectory of a space rocket. But the pupils won't need a degree in computer programming, as Chris is using a specially built website that already has instructions and computer code they can download to kickstart their project.
When we prepare for a STEM activity in a school, we can assume that there's no prior knowledge of either electronics or software. So we try to provide all the tools and resources available, so someone with no experience can get going quite quickly. One thing that we do think is absolutely critical is to make sure that the students get an early win. So if they spend 5 minutes of effort, they should get some result at the end of it. I think if they have to spend an hour before anything will work, and then at the end of it doesn't work, that's the sort of experience that would turn them away from STEM quite quickly.
Straight away, the girls on the robot team are having to get to grips with how understanding mathematics is fundamental to controlling a robot.
Have you done all the maths problems where a train leaves the station at this time and it's going at that speed? Okay, so basically it's those sort of maths principles where when you're sitting in class you can't necessarily understand why the hell you'd want to learn that.
Yeah.
Well, actually in the real world, everything's controlled by numbers, so being able to understand how to relate numbers to the real world is really, really good. So I think your first task is, if we measure out a 30-centimetre section on the table, you can work out numerically what you need to do to drive it that 30 centimetres. Okay. So eventually we can build on that and make a little maze.
Meanwhile, the rocket team are having to use all their skills in design and technology to put the rocket together.
You've got this connected to that, then you've got the nose cone at top. And the rocket fires, and when it gets to the when the rocket's burnt out, it does an explosive charge which blows this nose cone off. And it's the blowing off of the nose cone that pulls the parachute out.
Having scientists come into school is really important for the students because it allows them to investigate areas of the real world which is very relevant to their actual curriculum. So it allows them to look at technology, allows them to look at different types of technology, but technology they often see ready wrapped and not something they see unwrapped and available to look at in all its natural forms, to program themselves, and actually realise that a lot of the things they use outside in the real world actually are quite simplistic in many ways, and actually they can access them and use that to help them build on what they do in their curriculum.
Chris's work life frequently spills over into his home life. He even has an electronics workshop in his garage, and he's only too happy to involve his young son, Henry, in his experiments.
Oh, you want to use the stapler, do you? My son Henry, I think, takes after me. He has a natural inquiring nature, so from an early age he would come out here and sit on my workbench and fiddle with things, and it's certainly something I'd encourage. I mean, obviously he's young enough to do anything practical or useful, but just the awareness of doing things with his hands, I think, is very useful. It's never too early to start them. Yeah, I mean, having a 2-year-old in a garage might seem a bit dangerous, but anything that he can really do damage with is always hidden away. And I don't actually leave him sort of unattended. Oh, there's some rocket stuff up there, isn't there?
Rocket stuff.
Okay. Yay. There you go. I'm hoping that the students will learn a couple of different things, actually. Firstly, the ones that are into electronics or have an interest in that sort of field, I'm hoping it's going to teach them that they can actually go away and do this themselves. So people always talk about what they can do, and it's converting people to talking about what I can do.
Back in the lab, another group of pupils are working on building an electronic rangefinder.
Yeah, we got a ruler. I measured for my hands, but it's kind of difficult because my hand's got contours on it. It's hard to know where from.
So you need like a flat surface.
And box and it works.
Okay, well, there we go. This is really cool. So have you seen the the house programs when they have estate agents using tape measures that just go beep?
Yeah.
Okay, that's basically what. Yeah, you've basically built what they've got. So actually, can you measure that? See what that is? 'Cause that says it's 28.46.
It's from there, so I made a mistake, so it's from...
Yeah, that's pretty accurate. I mean, that's within a few millimetres, isn't it?
Yeah.
So if you was measuring the size of a room or something, that would be close enough.
Yeah. Yeah, it's been good fun. I haven't done anything with programming before. It was nice to have a go at it because it's just interesting.
The members of the final team are trying to get their heads around a locking mechanism project, an innovative idea that Chris hopes will capture their imaginations.
So it's your numbering system, I shouldn't.
That's right.
Chris developed this idea back in his garage.
Okay, so in preparation for today's event, the guys at Linton Village College have made these rather nice sort of MDF lidded boxes for us. And the project is to use some components such as these. So this little device here is an accelerometer, like you'd find in a Nintendo Wii. So it can actually, using the Earth's gravitational field, it can actually know its position in space. We have this little black thing here at the bottom, that's a servo motor. So you'd commonly find these in radio-controlled toys. So the students having this project today, what they'll be doing is using the servo motor to control a lock from the inside. The idea would be then to set the combination for the box simply by changing its orientation in space. So where you'd normally type in some kind of numerical sequence, we're actually going to be putting in a spatial sequence. And of course, once the box has locked itself, the only way to unlock it is to wind it back through the same sequence of orientations in space. So we think it's a bit novel.
It's very accurate because it gives me in 3 decimal places. But as you can see on the screen, you get odd numbers.
Yeah.
Although the locking mechanism is working and the data is being collected, it will take another session before the lock is fully functional.
I've always wanted to be an engineer since day one. I remember being very, very young and dismantling things which possibly I shouldn't have done. So in some ways it was a foregone conclusion that I would study maths and physics, go to university, do an engineering degree and then see where it took me. The only real decision I had to make was which field of engineering I wanted to go into. And at the age of about 14, sort of electronics really sort of appealed to me. And as they say, the rest is history.
Meanwhile, the robot girls have mapped out a course and are taking robot driving lessons.
Perfect. Okay, so how far do we think this is going to be? Probably about 1,200. 1,100? 990. Try 900. Let's try again. So what was it? That's better. We don't tend to do this sort of thing in lessons very often, so to do it sort of extra is really fun and really interesting. Teaches you a lot, actually.
Well, each of the 4 projects are really quite ambitious, so in many ways I wouldn't expect all of them to be finished, but the really good thing is each of the different projects and the teams doing them have got a good win. So the robot guys are driving the robots around, the rocket guys have got acceleration data, the ultrasound tape measure guys something measuring within a few millimetres accuracy, so I think they've all hopefully learned something really useful today.
With the rocket nearly complete, the pupils are having to consider the weight of the electronics that it will have to carry.
There are two ways to do this, depending on how much you put in.
Okay, what's the 2 ways?
Well, there are flights with medium to heavy payload and flights with nothing or very light.
Should we do a very light one?
Yeah.
Yeah, we'll do a very light payload.
Yeah, it's been really fun. It's been like a new experience for me and learning about how it works and getting to build a rocket, so yeah, I've liked it. I've definitely had to use technology a lot, like building the rocket and the circuit board and that. Science I don't think I used so much, but the maths I had doing the programming and that, so yeah.
Tie that to there.
Parachute.
Yeah.
The electronics in the payload will be recording data about the rocket's flight path.
And as the rocket fires, this device is going to be generating all sorts of acceleration information. Well, initially, it's just going to be acceleration in all three dimensions. But of course, from that, you can do some mathematics. And if you understand physics, which is obviously where the STEM comes in, you can do all sorts of tricks to find out things like the maximum speed it reached, the maximum height it reached. And with 3 axes of acceleration, you could also plot the actual, the flight path through space. So yeah, going from just a simple electronics project with the application of maths and physics, you could do some fairly sophisticated things.
Out on the playing field, it's time to set up mission control and start the countdown.
Lots of things could go wrong. We've done a few of these launches before. Sometimes the rockets don't ever come back, which means you lose your data and, of course, all the hardware in it. Not actually switching the data logging on is a foolish mistake that we sometimes make. Also, because of the acceleration that these things undergo as well, they can actually mechanically fail on the way up. But with those 3 things sort of withstanding, I'm sure we'll be able to get some interesting information out of this.
So count down from 5. Yep, and then push down the button, count down from 5 loudly.
5, 4, 3, 2, 1.
It was good pushing the button because when you actually pushed it, you actually felt the electric shock go all the way through to the rocket.
It was fun. I was expecting the parachute to come out, but when it didn't, it was kind of surprising.
The failure of the parachute meant they lost the vital payload. The pupils ended up searching the bushes in vain rather than analysing the data. Still, there's always next time.
I think today went really well, actually. Each of the 4 projects that we set were ambitious in their own rights. So the fact that all the groups managed to get some outcomes was quite impressive.
We'll follow up this activity by using that sort of data that we collect across all their classes. The students will feed back in assemblies to give an insight into what they've been doing today, and we can use the data in maths, in science, in technology, and also feed into the GCSE classes, especially the ones doing engineering.
It just needs to be.
I'd hope some of them have gone away inspired. They've used the sort of technology that, although they don't know it, they have in their pockets, in their cell phones, in mobile devices. So in some ways, they've seen what's on the other side of the plastic case, and I'd kind of hope that makes them think more about the sort of technology they have around them and how they can actually get involved in it.